In this video, you'll see how to find prime factors of numbers. So first, let's get down this definition. Fundamental theorem of arithmetic. And this was given to us by a Greek mathematician named Euclid. And it states that every composite number, so that's a number with more than two factors, can be written as a unique product of prime numbers. And remember, when we say product, that means we are multiplying numbers together. And so when we do this, it's called finding the prime factors of a number, which we're going to see right now. So let's take a look at a sample problem. Prime factorization. We use what we call the cake method for this. So we're going to start with the smallest prime that goes into a number, and then we're going to keep using that until it no longer divides into the number. You're going to choose the next smallest prime and repeat until you get a 1 at the top of your cake, and then write your final answer in exponential form. So let's see what this looks like. Think about a small prime number that goes into 72. Well, the smallest prime that goes in is 2. 2 divides into 72 36 times. Now, can I keep using 2 to divide 36? Sure. 2 goes into 36 18 times. And I can keep using 2 to divide 18. 2 goes into 18 9 times. See, this is why we call it the cake method. This looks like the layers of cake. Now, 2 will not divide into 9, but what's another prime number that divides into 9? 3 will divide into 9. And 3 goes into 9 3 times. What's a prime number that goes into 3? Well, the only prime that goes into 3 is 3, because 3 is prime. And I got my 1 on top of my cake. Make a little candle there. So these are all the prime factors that make up 72. So I want to express this in exponential form. So if I multiply 2 times 2 times 2 times 3 times 3, I would get 72. Well, 2 times 2 times 2, that's equal to 2 to the third power, times 3 times 3, that's 3 squared. All right, let's take a look at one more example here. So I want to find the prime factors of 120. I'm going to divide by 2 because it's even. I get 60. Divide that by 2. I get 30. Can still divide that by 2. I get 15. 15, I can't divide it by 2, but I could divide it by 3 and get 5. And 5, I can divide by 5 and get 1 at the top. I want to write this in exponential form. So it's 2 times 2 times 2, which is 2 to the third power, times 3 times 5. To check this out, 2 to the third is 8. 8 times 3 times 5. And 8 times 3 is 24. And if I multiply 24 times 5, I'm going to get 120. Now, do you have to start with the smallest prime? No, you don't. I could, if I wanted to, I could start with, like, let's say I could start with 5 if I wanted to. And if I knew that 5 goes into 120 24 times, then I could use 3. 3 goes into 24 8 times. 2 goes into 8 4 times. 2 goes into 2 goes into 4 twice. And then 2 goes into 2 once. Notice I get the same prime factors, though. This is still 2 to the third times 3 times 5. Alright, here are a couple problems for you to practice on your own. Find the prime factors of 84 and express that in exponential form. Alright, well, I'm going to use 2. 2 goes into 84 42 times. I'm going to use 2 again. 2 goes into 42 21 times. 2 won't go into 21, but 3 will. 3 will go in 7 times. And 7 goes into 7 once. So 84, the prime factors of 84 in exponential form, 2 squared times 3 times 7. And I can check this work. 7 times 3 is 21. 2 times 2 is 4. 21 times 4 gives me 84, so it checks out. Alright, and last I want to find the prime factors of 252. So I'm going to divide this by 2. Well, 2 will go into 252 126 times. 2 will go into 126 63 times. 2 won't go into 63, but 3 will. 3 will go into 63 21 times. And then 21 can be divided by 3 again. And I'll get 7. 7 goes into 7 once. The prime factors of 252 are 2 squared times 3 squared times 7. And that's how we find prime factors of numbers.